I'm super excited today because we will talk about Chernobyl and radioactive waste and overall about some of this catastrophe, nuclear catastrophe, and science behind it. So it's my great pleasure to introduce my dear colleague, Dr. Ramilla Brikova, who is a biologist and her research focuses on the environmental behavior of trace elements and radionuclides in soils. Her doctoral work investigated the dynamics of Strontium-90 in soil systems and is transferred to plants. Currently, she studies the geochemistry of mercury of the Environmental Geochemistry Laboratory, Institute of Geology, Czech Academy of Sciences, and today she is joining us from Prague. And the reason why I asked her to give this lecture because she actually visited Chernobyl years before COVID, like 2018 or 2017. You can tell us, Ramila, about your own experience of visiting the site. That's why I thought it was such a unique opportunity for me to invite her to share her experiences, but also as a scientist, biologist, ecologist, talking about the science of this nuclear waste and the catastrophe overall.
Spellings for Chernobyl above are correct. Just don't be confused if you find papers. In some you will see Chernobyl, in some Chernobyl is the same city and the same nuclear power plant. And before I will start talking about Chernobyl, I want to show you the current situation about nuclear power reactors in the world, which are under construction, which are abundant, operating. And so you see that we really have quite a lot of nuclear reactors worldwide. Maybe Australia is only one country which is safe in case of nuclear power plants. And Chernobyl is also a nuclear power plant. It's a name after the city, Chernobyl, and it's located now in Ukraine. And here you can see where it's in the world map. And does anyone know if Chernobyl nuclear power plant is operating or not nowadays? Does anyone know?
You can speak up or write in chat.
Yeah, both is okay. So I will tell you that no, unfortunately, Chernobyl is not operating right now because, I see there is something in the chat. Not. So correct answer. And no, it's not. But I guess it's one of the most famous nuclear power plants in the world. And it's not because of it's really high efficient and something. It's opposite. It's because of on April 26 in 1986, there was happening a big explosion and big disaster. And it is the most severe nuclear accident in history which occurred, and it's resulting because of safety. It happened during safety tests, but and led very not safe consequences. So just in 40 seconds after this test was starting, I don't know if you see the picture, it's a fourth reactor, now how it was looking after the accident, and the big concrete roof just flew away because of this big explosion. And there were actually two explosions, one 2-3 seconds for the gap between these two explosions, and the second one was the most severe. And so there is the reason why it's happened. It's because of miscalculations and yes, human factor. It was the reason why it's happened. It just was a wrong protocol, and we have what we have. So here are some casualties. It were 2 immediate deaths and 28 from acute radiation within weeks. And here you can see how about 10 days after the Chernobyl explosion, the radioactive materials were spread across much of the northern hemisphere. You see, even in US, you can find that there were radioactive materials which reached in 10 days almost throughout whole northern hemisphere. Of course, large amounts were deposited in Europe, but still, in 36 hours, whole city Pripyat, which is close to Chernobyl, was evacuated, and there was established 30 kilometers exclusion zone around the Chernobyl nuclear power plant. And it's restricted till today to, you can't go there just without any permissions. And here's just to understand the scale of the disaster, the release of radioactive materials, how big it was in comparison to Fukushima and Hiroshima. So it's like, I don't know, almost 200 times higher release of radioactive materials in our poor Earth. And so the Chernobyl accident, it has three major impacts are divided to three main categories. First are physical impacts, which include serious health effects among the population and long-term environmental contamination by radioactive substances. Second is psychosocial impacts on the affected population, because many people were experienced in stress, anxiety, displacement, and long-term uncertainty about their health. So had a really strong impact on psychological. And the third is influence of the accident on the nuclear industry worldwide. For example, in Germany, they shut down all nuclear power plants, and the regulations became more strict, and design of nuclear reactors now are really improved, and it led to increase the international cooperation in nuclear safety. Of course, it would be better if it had been done in advance before this happened, but we have. And so the major releases from this accident were radioactive gases were directly emitted into the atmosphere, and these gases were spread quickly over long distances and contributed to the large-scale atmospheric deposition of contamination of these radioactive materials. The less labeled are condensed aerosols, and they were also released. And these are the small radioactive particles formed from the vapors materials and condensed with a cooling air, because it was end of April. It was not summer, so it condensed aerosols deposited then on the top of the soil and trees. And the last one are fuel particles, and they were released from the damaged core of this reactor. And these particles contains fragments of the nuclear fuel, and they are quite stable. Even now, you can find these fuel particles which are not decomposed in the soils. And here's on the map the distribution of these radioactive materials so the black here is the nuclear power plant. So what is the current situation in Chernobyl? So it's the area which is affected, it still remains restricted. So there's this 30 kilometers exclusion zone, but it's not completely abandoned. I just wanted you to highlight there are almost 3,000 people which are regularly work in this exclusion zone, and they are the people who are working there involved in many important activities, such are monitoring the site of the nuclear power plant, and they conducting the radiation monitoring and decommission old facilities. So there's also a new safe confinement structure that covers the damaged reactor. I will show you later. So here is a dosimeter, and it's me who made this film. And here you can see, and please remember or write down the dose, which you will see at the end of this video. So it's me walking in Chernobyl exclusion zone, and here you can see how the numbers change. There is no sound, but it is really not happy with the numbers. So 32 and 13 microsieverts per hour. So at the end of the lecture, we will calculate, was it safe or not to be next to this source of radioactivity? And so it's my photo from the abandoned village. So we can see this deurbanization of the area, how plants are destroying the human-made stuff. And so Chernobyl is really unique site because you can study the urbanization, for example, at this sites, and there are a lot of other research in radioecological studies and radiobiological. Recently, I found interesting paper about the mutagenesis of dogs from Chernobyl. So they sequenced the DNA from the dogs and found some parts which are really mutated. So the casualties of this. So it's really, from the research point of view, it's really unique. And that's why I went there, because I wanted also to study something what is happening. So it's like a huge isotopic lab where you can study distinct interactions. So, and in 2012, we were published the International Radioecology Center, and they were organizing summer schools, which I was also participated. So, but now we, unfortunately, it's not possible because it's not safe to organize this summer school. So it's temporarily not ongoing project. And here are the sediments from the Chernobyl nuclear power cooling pond. There was a cooling pond where it's typical for nuclear reactors, big nuclear reactors, to have the ponds nearby to cool the system. And now ecologists studying the sediments from this pond. And here you can see that the radioactivity is not uniformly spread in the sediments. This is X-ray radiography of the sediment profiles, and scientists can study how it's now deposited in aquatic environment over time. But one of the main issues which are now in these exclusion zones is the forest fires, because they're quite common for this region, and it's still environmental concern because the forest accumulating a significant amount of radioactive material because trees are able to translocate these radioactive materials to leaves, and then they are burning. These radioactive materials are releasing to the environment, and it makes a concern. But so it's one of the current problems, but fortunately it's not so bad. So of course it's not good to walk when it's fire there, but it's somehow not spread it's much far from these exclusion zones. So these 30 kilometers, it's really have buffering sites, which helps the other zones to keep them not clean enough to live or to walk for several hours. So here you can see the content of Cesium-137 in different part of the trees and in litter and mineral soils. So we can see that it's really plants like cesium. And of course, the war which is now ongoing in Ukraine, it's also had an impact on the current situation because, for example, 1 year ago, this new safe confinement, which was building, I don't know how many years, many countries, a lot of monies to build this confinement. And last year it was damaged with drone. And now International Atomic Energy Agency concluded that it can't protect environment as it did before. So it's current situation now. And I also added some slides for you to understand what is radioactivity, why it's dangerous, but it's really briefly, and I don't want to go deep into chemistry and physics. I just want you to have to know the basic why it is radioactivity is so dangerous. So the thing is that radioactive waste, they have a capacity to ionize the molecules because the usual energy between bonds are 1033 electron volts, and the radioactive materials have capacity to damage these bonds because the energy, do you see what is the energy? Yeah, because I had to move. So you see, I don't know, 100,000 times higher energy than the bonds, so it can damage directly the molecular bonds, and there are direct damage of DNAs and indirect by free radicals. So it's the reason why it's so dangerous, because it's really has very high ionizing capacity. And of course, this energy depends on the type of radioactive materials, and there are, please just remember this. It's important because when we choose how to protect ourselves, we should know that radioactive there are different decays and different particles which are emitted from radioactive materials, and knowing the source of contamination, we can protect ourselves. So there are alpha, beta, and gamma decay. Actually, it's not correct because it's not decay. Decay is when atom changed to another one. In gamma case it doesn't change, but it's so because of these decays, we're emitting 3 different particles and photons, and the most heavier and having the higher energies are alpha particles, and they have the highest ionizing effect, but they can't stop by sheet of paper. So it's not really dangerous when it's even on your table if you don't want to eat it. It's because even our skin, it's able to protect us from these alpha radioactive materials. Beta particles have more penetration because they are electrons and positrons. They can fly more and they can penetrate few millimeters, but still, even, for example, I was working with Strontium-90 and it's beta decay and beta particles. So wearing a glass for my eyes were enough to protect myself. And I was not willing to eat it. And gamma rays have the highest penetrating ability, and to protect yourself, you need to have really big, dense materials, concretes to protect yourself. It happened. Maybe if you read history about Chernobyl, that it was hidden that it happened, and then the Swedish research centers they measured the high radiation which is coming somewhere from the southeast. And now you know that they measured gamma radiation. Yeah, so it is the main. Sorry, I will just. And to understand how to protect yourself, it's important to know not only the particles which are emitting during the radioactive contamination, but also which radionuclides released. For example, I told you that I worked with Strontium-90 and it's beta. So we should know the main radionuclides. So the main, for first days, the main source of fear, it was iodine-131, and it caused an increasing of thyroid cancer because it's also iodine which we really need for our health. So our thyroid was happy to find it in the air and it absorbed, but it was radioactive. So it's almost 6,000 people claimed that they got cancer from this iodine 131. So it was, but now it's not the big concern in Chernobyl exclusion zone because the half-life of this radionuclide is 8 days. So it's a short-term concern. The next is Cesium-137, and it dominates long-term soil contamination due to it's not 8 days or it's 30 years half-life. So that's why it's the main concern for us our days. And till nowadays, the topsoil levels near the zone reach thousands kilobecquerel per meter. So it's really high. I don't want to go deep in how we measure it because we need another 3 lectures. But so it's really like the dominates in soils right now. Strontium-90, it's the main. It's really dangerous because it's analog of calcium for as a chemical, and so it's really mobile and it's migrate to plants to food chain, so it's big concern and through livestock to the milk and then to us, to people, to children are really highly exposed to this contaminated milk first year after disaster when it was not such policy was not established yet how to treat these areas and what to do with this. And plutonium and uranium particles, fuel particles, very persistent soils, as we name it, hot particles. And so they are in these fuel particles which are not degraded. They are source of alpha particles, so and their half-lives are 1,000 years, so it's a still big concern. And these hot particles, they have limit weathering process where they weather in this year is 40 years. It's anniversary of this disaster, and there still remained a lot of fuel particles in soil. So why soil is critical? So first, it acts as a sink for radionuclides, trapping them and preventing the immediate spread. It also controls migration to groundwater, and so it affects the water safety. and it determines transfer to crops and influencing the food contamination. And it, of course, affects the long-term human exposure. So it's why it's important to study soils and to know how radioactive materials deposited there and how mobile they are in these soils. So I added also some links to nice papers which you can read to know more what is happening now in Chernobyl soils. And so mechanism of soil contamination, it was radionuclides rich soil by dry deposition, where particles settle directly from the air, and wet deposition, it when they brought down by radioactive rains. And here is a map. Here's a map, and you can see that the highest contamination occurs in 10 kilometers next to the plant. Main factor, you guys are right, it's because of wind and rains. So meteorological conditions were led to this ununiformly spread of radioactive materials and forests. And so there are main factors why it's not uniformly distributed. So I could say that Kiev was lucky, but it was north. The wind was from south to the north, because it was not so affected. It's the biggest megapolis in this area. So we were really lucky, I could say. Next, I don't know if I'm not too slow. Maybe I have to be more quicker. So is my question, why distribution is not uniform. So here are the profile distribution of radionuclides in podzolic soil. And you see that the most of the radioactive materials are concentrated in the first in organic material in the first 5 centimeters of the soil. So it's not mobile, not moving deeper. So soil really protects us from this contamination of water. More about the less amount of mineral composition of soil which can bind radioactive materials. But it's really good that you considered the cation exchange capacity of the soils, that it's really important for holding particles and ions. And you see here that it's also depend on the radionuclide. So what is also determined by soil is transfer to plants. In radiology, we call it transfer factors. It's amount of radioactivity, radioactive materials which can be absorbed by plants. And they are really plants like Cesium and Strontium-90, and they really have a high tolerance to radioactivity, and they can grow and they are fine. And people can't recognize if they were exposed or not, and then they can go to food chain with radioactive plants and we can be exposed easily. And so people should be aware that if a plant looks healthy, it doesn't mean that it's safe to eat. Especially mushrooms, they love radioactivity. There are a lot of hyperaccumulators, ferns, for example, and mushrooms, they are really high hyperaccumulators of even heavy metals, not only radioactive substances. Yeah, right? So factors which are influencing the transfer to soil pH, clay content, organic matter, mineral composition, and of course plant species. So these are the main factors which are influencing on the transfer of radioactive materials from soils to plants. And here, for you as a soil scientist, it would be interesting, I think, to know that the different soil type, they have different transfer factors of the same plant on different soils. So we can see that the maximum of Cesium-137 accumulation plants you can find in sandy podzolic soils, but for the same for Strontium-90, because you see plants can really easily absorb it from the soils, and up to 4 transfer factors for Strontium-90 in sandy loam. And here I want to tell you some approaches how to remediate soils from the from radioactive waste, and there are different methods which we can use to decontaminate our soils, and there are, I could say that almost all of them quite costly with this chemical approach, and people use it mostly in this with handling the waste from nuclear power plants. And so usually we don't use it in Chernobyl exclusion zone. And so there are different chemical approaches. I also added the link to the paper, which is really nice. It's a comprehensive review of the different approaches, how to handle this waste and how to clean our soils from the radionuclide. And usually many managers use them only for the really small areas because it's quite costly. So there are different chemicals and approaches which can be used, and they are quite effective. But usually we use both chemical and physical. And so there are different adsorbents and materials which can bind radionuclides and make them less mobile. And physical approaches, they often combined with chemical, and they show the high effectiveness in removing. And but soil types, we should consider that soil type really impacts on the using different approach, because for example, soils which consist kaolinite, they have less low permeability, and electrokinetic techniques could be limited in these areas. So it's before using different approach, and we should know what is of course, the main radionuclides from which we are trying to save and clean our soils, because, for example, uranium could precipitate during these electrokinetic techniques. So they precipitate near cathodes. So we should really, before choosing the approach, we should know what is our soil, what source of contamination we are going to clean it. We also have wash our soils, yes, soil washing. But yes, usually washing is we are doing with chemicals. So it's not just washing with water. And so combining this approach really highly effective. So this vitrification techniques, they're making, but it's really super costly, and it's when you you turn your material to a glass-like materials. It's vitrification technique, and it's encapsule the radionuclides inside, so they gonna be not so degradable. Like these fuel particles, which we find in the soils, it could be like also. It's a vitrification technique which will have been done before it was released. And the phytoremediation approach is the most eco-friendly, and it's cost effective, and we can find the plant species which really can accumulate the high amounts of radionuclides when we harvest the plants and do some of this physical chemical approach to save our soils. So I could say the most cost-effective and eco-friendly approach. And we wanted to tell you the last minute, and we can there are three ways to save ourselves: is limiting time, distance, shielding. And if we protect humans, here you see in the graph mammals, we will protect everyone, because humans are the most sensitive to the radiation. And the best way to make soil safe is prevention, of course, of radioactive contamination. This is how this waste storage look like. There are strict regulation, and here are some links. So there are different environmental monitoring programs. It's really nice online map when we can see what is dose of radionuclides right now. And here I just wanted you to know that it's the radiation. There are also a lot of the normal occurrences of radiation, cosmic and terrestrial, in bananas. But don't be afraid, it can accumulate. So you eat it, and so it's your radon zone map in US. So it's what should we do if nuclear war starts? So some tips. It's good to have the potassium iodide at home, because it's really dangerous.